I'm going to review for your quiz that you have. So the game plan is if you could go through this whole review and then you will be ready to take the quiz. I would do it immediately. As soon as you finish this review, go straight into the quiz. You could even play back this review during the quiz if you need some help. So I'm going to take you through an entire Delta Math of what you're going to need to know on the quiz. And I'm going to go question at a time, topic at a time, so you get to see everything that I'm going to ask. So the first one that you're going to be asked is you're going to be asked to, looking at a couple inequalities, figure out which point would not be a solution to the system. So to do this, a lot of this is just kind of plug and chug. So you're plugging in and seeing if I plug in 5 for x and negative 5 for y, does it make both statements true? And we're looking for the one that doesn't make it true. So we'll start with 5. If I put 5 in here, 4/5 times 5 is 4, minus 2 is negative 6. So this is saying, is negative 5 less than negative 6? Well, I think I already found the one that's not true. I'm going to try it in the other one as well, just to make sure. So I'm going to put 5 over here into the second inequality. So negative 3 times 5 is negative 15. Negative 15 plus 7 is negative 8. So is negative 5 greater than negative 8? That one is true, but I don't think it makes the first one true. Let me double check. I have 5. When I put that in there, I get 4. Oh, no, this one does work. When I put 5 in there, I get 4 minus 2, which is 2. Negative 5 is less than 2. So that first point's going to work in both. So I'm going to go to 10, negative 8. So when I put 10 in, 4/5 times 10 is 8. 8 minus 2 is 6. So is negative 8 less than 6? That is true. And then I'm going to put 10 over here. So I have negative 30 plus 7 is negative 23. Negative 8 is greater than negative 23. So that point's true. Next one, when I put 5 in, 4/5 times 5 is 4, minus 2 is 2. Negative 6 is your y value. That is less than 2. That's true. When I put it in here, I get negative 15 plus 7. That is negative 8. Negative 6 is bigger than negative 8. That one's true. All right, it must be this last one. If I put negative 10 in, I get 4/5 times negative 10 is negative 8, minus 2. Negative 8 minus 2 is negative 10. Negative 7 is less than negative 10. That is not true. So it took a while, but I finally found the one that was not going to make both true. And once I find it, you should be doing this with a calculator. I'm trying to do it all in my head, but a calculator would definitely save time. All right, next one that you're going to be asked to do is you're going to be asked to graph. So when you're asked to graph, you're going to graph each one separately. These are in slope-intercept form. So I'm going to start at the y-intercept, which is negative 4. And then my slope is 1. So I'm going to go up 1 over 1. I'm going to change the line to a dotted line because it doesn't have the equal to, and I'm going to shade underneath. There we go. That's the first one. Next one has a y-intercept of 5, so I'm going to start at 5. And the slope is negative, so I'm going to go down 1, right 2. There's my line. I am going to keep it solid because it has the equal to, and then my shading needs to be above that line. So not that one. I want that one. So my region, we call it my feasible region, is going to be here. This kind of like a greenish teal color. Then you're going to have to put a point that falls in that double shaded region. So I'm going to go over to 9 and up 2. Any point in there will work. It doesn't have to be a certain point. It can be just anything that's in that overlap. And then you're going to enter that. Next thing, this is going to be a very similar one. You're going to be asked to graph and find a solution point. So again, these are in slope-intercept form. So I'm going to start at 3, and then I'm going to go up 1 over 5. That has no equal to, so I'm going to change it to a dotted line. And it's a greater than, so I'm going to shade it above. Then I'm going to do the next one. So I'm going to start at negative 1 as my y-intercept, and I'm going to go down, because it's a negative slope, down 3, right 5. This one should be solid because it has the equal to, and it should also be above. So change my shade. So my overlap now, again, I like how the Delta Math puts it almost like in this darker teal color, is right here. And any point in there I'm going to enter. So I'm going to enter something right on the y-axis. I'm going to put the point 0.6. And any point that falls into that double shaded region is acceptable. And that's it. So those are your graphing your systems of inequalities. Now we're going to move on to linear programming, or sometimes it's called optimization, finding maximums and finding minimums. You can even see the topic here. So this is a multiple choice question. They give you the feasible region already. It's this bounded feasible region. And they also tell you all the vertices. The vertices are the keys to finding out whether it has what the minimum is or what the maximum is. This particular question wants to know the maximum value. This is your objective function. So you're going to be plugging the vertices into that objective function. And we're looking for the highest number we get. Well, 0, 0, if I plug 0, 0 in, I'm going to get 0. So that's not going to be my maximum. If I put 0, 10 in, when I put 0 in for x and 10 in for y, I'm going to get 10. So that vertex gives me 10. When I put 20, 20 in, and again, you can grab a calculator. I think it's nice to have that close. So 6 times 20 is 120 plus 20, that's 140. So right now, that's the winner so far. Then I'm going to put 45, 15 in. So 6 times 45. And here, let me show you about my calculator. If you want, you can just jump on a calculator, type in 6 times 45, and then plus the y value is 15. I get 285, which is definitely the highest thing I'm seeing so far. I am going to do a quick double check. When I put 40, 0 in, 6 times 40 is 240, plus 0 is still 240. So the highest value I'm getting, my maximum is my highest, is E, 285. Submit that. Here I want to talk about how do you know if you get a maximum, a minimum, or both. So we have two different types of feasible regions. We have bounded regions. Bounded regions means it's entirely enclosed. It's going to make kind of like a geometric type shape, even if it's like an oddball type shape. It's an enclosed figure. If it is enclosed, it will have a minimum and a maximum. Whatever your highest number that you get when you plug in your vertices would be your maximum, whatever your lowest number is your minimum. If it's not bounded, like this one is unbounded, then it's only going to have one or the other. And here's how you tell. If it's bounded above, so if you look at this shaded gray region and you notice the boundary is above it, then it's going to have a maximum. If it's bounded below, so let's say the flip side was shaded and it had a lower boundary, then it's going to have a minimum, but it will not have both. So for this one, since it's bounded above, it's going to have a maximum. And I'm going to submit my answer. Finally, we get to actually setting up some of these linear programming problems. So I'm going to do a couple where I want you to practice writing the objective function. So your objective function is going to be what you're trying to optimize, what you want a maximum of or a minimum of. So in this case, we are trying to maximize profit. So my equation, and we're just writing it in the form C equals AX plus BY. So I'm going to write C equals my profit. So I make $9 on party dresses and I make $4 on casual sets. So my profit is going to be $9 on one type plus $4 on the other. And again, I'm going to be pretty flexible with your variables as long as you have the two variables, just make them X and Y, and then you have the correct coefficients. Show you another one like that. So this one, you are purchasing file cabinets and you're trying to maximize storage space. So you want to look where you see the word maximize or minimize. So if I'm maximizing storage space, then my objective function is going to be about storage space. So again, we're going to go in the form C equals. So let's look at our cabinets. We have two cabinets, cabinet A and cabinet B. Cabinet A has a storage space of 12 cubic feet. So storage space means the same thing as storage capacity. So cabinet A has 12. So I'm going to write 12x. Cabinet B, read a little bit further, has a storage capacity of 18 cubic feet. So 18y. And that is what I'm trying to maximize. So that is my objective function. So I'm going to submit that one. And I've just got one left for our review here. So here's the same question, but now we're actually going to write the constraints. So the constraints are going to be what you are limited by. You're going to have 4 constraints. It actually tells you there are 4 inequalities you're going to write. We're going to use X for cabinet A, and we're going to use Y for cabinet B. So your first 2 inequalities are going to be really simple. When you're dealing with something in real life, in this case, like a storage cabinet, or if you're dealing with money and you're making something, you can't have negative. So 2 of my constraints will always be that your X has to be greater than or equal to 0, and your Y has to be greater than or equal to 0, because you can't have negative values when we're working with these real life quantities. So those are going to be the 2 really easy ones. Then we're going to read the problem and see what else are we restricted by? What are the things that kind of hold us to only being limited by certain things? So what I have here is I know that I only have 60 square feet of floor space, and I am working with cabinet A takes 3 feet of floor space, and B is going to be 6 feet of floor space. So if I take 3 feet for cabinet A and 6 feet for cabinet B, and I only have 60 feet to use, then it has to stay less than or equal to 60 because I am limited by how much floor space I have. Cabinet A is going to use up 3, cabinet B is going to use up 6, and I only have 60 to work with. My last inequality is going to be I'm limited by my budget in this case. I have $600 that I can spend. I'm going to spend $75 on cabinet A, and I'm going to spend $50 on cabinet B. So 75 cabinet A is X plus $50 that I spend on cabinet B, which is Y, and that has to stay under, so less than or equal to, my budget of $600. So there are all of my constraints. The first two are going to be true every single one you write because we're working with real life quantities that can't be negative. The third and the fourth one are going to be ones that you're going to have to read a little bit and figure out what are we limited by. And in this case, we're limited by floor space and we're limited by money. We're going to submit our answer. Oh, and I typed something in wrong. What did I type in wrong? Budget of that. 600 in the budget. I just might have this typed in wrong. 3x plus 4y or 6y. I think I have everything here. All right. That one is right. I think I have an incorrect error in my program. Or maybe I feel like I typed everything in right. So I have 60 feet of floor space. So 3x plus 6y has to be less than or equal to 60. And I have 600 in the budget. So 75x plus 50y is less than or equal to 600. Nope, that's right. I think there's just the way that it was typed in. So that's what you're doing for that one. And that is everything you need to know to be ready for the quiz. I will go through, especially for things like this that have multiple answers, I will hand grade them on the quiz. So if you have a couple of the inequalities right and a couple wrong, I will still give you credit for that. Make sure you're showing all of your work and then attaching a picture of your work to the Google post, and good luck on your quiz. You guys are going to be great.